Yes.
Good. Okay. So previous time, I mean, we talk about some analysis of some formula that was for quick sort, but I mentioned that these are some useful formulas that you need to know. This is the arithmetic series that the number from 1 to n, the sum of them would be n times n plus 1 over 2. And in general, if we have an equal to an plus 1 plus c, and then we have sum of a1 to an, then this would be n times an plus a1, the last term plus first term over 2, when c is constant. This is called the arithmetic series. We had this concept of a geometric series as well, that if you have 1 plus 2 to the n, then it is 2 to the n plus 1 minus 1. And here, this is a geometric series that an is equal to c times an minus 1. And c, we are assuming, is not equal to 1, but still a constant. Then in this case, the sum of a1 to an would be a1 to the cn minus 1 over c minus 1. And we mentioned that if c is less than 1, then sum of these ai's are equal to 1 to infinity would be a1 over 1 minus c. So the first term, and this was a particular example that we mentioned, 1 plus 1 half plus 1 fourth, so on. When it goes to infinity, this is actually, so just, yeah. So this is actually equal to in the infinity, it goes to 1 half. Sorry, it goes to 2 by this formula, because a1 is here is 1, and 1 minus 1 over c is equal to 1 half, so it would be 1 half, 1 over 1 half, which is equal to 2. So this is the one that we have discussed. We mentioned about the sum of squares, I equal to 1 to I square, n times n plus 1 times 2n plus 1 over 6. You can, there are, this is the things, you can also see the formula, search it for I equal to 1 to n. This is I, like I to the 3 as well. You can find the formula. So one other thing is also to get this I square. Actually, if you do this I square, you can also write it in terms of sum of, in terms of this sum. This is the sum of these guys, just I. So if you expand this formula, you can actually get it from here, or you can get it from induction. This is the one that you can search for it as well. Good. We talk about the harmonic series. That's very important. That's one of the important things. From k equal to 1 to n, 1 over k, which is equal to ln of n plus this gamma, which is the Euler constant 0.55, plus some little o of 1 over n. And I mentioned that there is a contrast between this guy and this guy. So if h of n and this one are very similar, this one has only sum of the term 1 plus 1 half plus 1 fourth. This has the full term 1 plus 1 half plus 1 third and others. This becomes ln of n or log n, and the others becomes the other one just becomes a constant. These are some formulas that are very important. Log ab is equal to 1 log of b over a. This you can actually get from this general formula. This is very important one. Log x in base a is equal to log x on base any b over log a on base b. So if you write this one, and you just you can just actually replace this one if you write it in terms of if b is equal to a, this you can get it from here. This is very important. B to the log b to the log x base b is equal to x, and in particular I mentioned that 2 to the log n is equal to actually n. This is the other formula. B to the log x in base a is equal to x to the log b base a. This is the, let me clear this one. We talk about sum of a square, sum of logarithms. So this is sum of the logarithm versus the sum of the numbers. So if you have this number, would be n times n plus 1. Here, if we have the logarithm from 1 to n, if we take the logarithm of these guys, is actually just equal to n plus 1 times log 2 of n. So in some sense, this is equal to n times the last summand, minus 2 to the log 2n of n, which is, this is, I mentioned, this is essentially n plus 2, which is, the whole thing is n log n. That's important because, so this is also related here, Stirling's approximation. So for n factorial, we know that it is equal to square root of 2 pi n, n over e to the n, 1 plus order 1 over n. So that is important because, as I mentioned, whenever you have n factorial, you can make this one n over e to the power of n. And this is a good approximation in some sense. So this is a very good approximation of n factorial. Whenever we have n factorial, it is essentially n over e to the n. That's the things. And there you can get the log 2 of n factorial, either based on this formula, which would be just n log n, or actually you can compute this using this formula as well. Why? Because log of n factorial would be log of 1 plus log of 2 plus log of 3 plus log of 4 and so on so forth. And we mentioned that this is equivalent to log of like n times log n. In some sense, actually, log of this sum, that this log of these guys from 1 to n, you can also get, because you know that this is equal to log of n factorial. So we know it is the case. And what was n factorial? N factorial was this one. So you can first write n factorial using this Stirling approximation, and you will take the log of this. Actually, if you do that, then you get this formula that we discussed. So this formula, that y log of n factorial is equal to this, actually, you can just using a Stirling approximation and get it that. Last but not least, summations by integration. That was very important that we discussed as well. That if you have the numbers from I to 1 to n, f of I, so you can, this is what's the idea, that if you have, that if you have some formula like this, if you have some summand like this, this has the f. Here, actually, we have assumed that f is a monotone increasing continuous function. So maybe this is not the correct thing for that. So the correct thing would be something like this. If you have such a things, you can always actually take, so instead of computing this sum, you can just take, so you can take the sum of these guys, but this is lower bounded by this formula. The formula from here, if you take the integration of this area, this would be upper, so this sum would be upper bounded by this. You can also take the lower bounded things. There are some formulas if you want to get the tighter things. So in some sense, summations and integrations are very similar to each other, and we can just approximate one with the other. Great. So any questions so far? So these are a set of useful formulas that would be good to know. Here, this is essentially, we are finishing the working with formulas. These formulas are very important, are in almost any papers that you are seeing there, because you want to do some computation. Sometimes you try to get a running time of the algorithm. Sometimes you try to get approximation of algorithm, like how good is this algorithm, or the space of this algorithm, or the number of rounds in the parallel settings, and so on and so forth. So there are several of these things that we are using with these numbers, and it is very important to that you are being very familiar with that. And also this is, for example, very important that I mentioned that log of x in any base, any constant, log 2, log e, log based in 10, all of them are essentially in the same order. So it is important that you are working, especially you are working easily with logarithms. Having said that, now we are going to the next things, and we talk about the data structures. Great. So here we are talking about the, data structures. We talk about some of these building blocks of any computer algorithms, and these are very important. And these data structures are also very related to databases. So because some of these data structures, actually we will save them in a databases, and these are the information. All this kind of online website that you are doing are based on the databases. So here we consider some kind of abstract data type, like in a sense that, this like some of this that we consider is that we do not specifically data types like integer, reals, characters, I don't know, strings now, or other things like float, etc. So we consider this one for any data type. So the data type generally is not that important anymore, because of this convenience that we have it. So before, for example, a string was a bit more like different from, you need to consider array, etc. But now even a string, for example, is something that is very standard in C++ or Python. So the modern object-oriented languages like C++ and Java, they are also forming the abstract data type that we will actually discuss it here. We will talk about STL in C++ here a little bit, which is very useful to know, both for your own sake. These are very fast things, and also for any interviews or something that you want to do it. If you are doing interview in C++, which is generally needed for if you are going as a software engineer. In data scientists, you might be able to do it with Python, but as a software engineer, generally they are checking essentially C++ or Java. These are the important things that you need to know. And as I mentioned, these are actually, they are providing this abstract data type that we will talk about it. So it is this ATT means abstract data type. Well, let me just clear our drawing. So here, this kind of the abstract data type, generally, we can see it like, for example, in C++, these are defined as a class, or like even Python, they are defined in class or Java. But Python is a class, is the one. In C++ also, you can do it a struct. A struct and class are very similar. Almost the same essentially. Just something about the inheritance, etc. is a bit different. If you have some function you want to use it, the default is a bit different. Now, when we talk about this, these are the elements. So these are the elements, essentially the one particular data type. They can be integers, they can be names, names or strings. Generally, we have numbers. We have strings. Strings is just a set of characters, and now almost in every language there is a default string. And sometimes there are pointers. Pointers also another one that we have it, especially in C and C++. That is also, we can have a set of pointers. And here we are assuming that on this string we are doing some basic operations. basic operations that we are talking, and here we are considering the strings of bonded lengths. The strings in particular, for example, in Python, it can be the whole file. You can say it as a one string, one big text essentially. In that case, of course, here we are talking some basic operations for them. When we talk about basic operations, we talk about basic operations on numbers or pointers or strings. So strings have strings or characters essentially. We are assuming these have a bonded length that you are doing that. Otherwise, the running time of, if you consider the whole big file, I don't know, a terabyte of text data as just one file, of course, then it is not order one. So we consider a smaller strings here, that the running time, the operations that we are doing on them is order one. That's essentially the basic elements. We can compare them. We can essentially increment them, decrement them, or we can concatenate them. And again, as long as these strings are like, sometimes you are considering strings of 256 bytes. So these are small ones that we are considering. Generally, strings are a bit slower than numbers and pointers. Good. So these are some kinds of elements that we often talk about them. So another very important thing that we have it here is the array. So array is essentially array is a raw set of elements. Good. So we have essentially an element of the same type. And the size of the array is the number of elements in that array. As we will see, actually, an operation that exists in C++ to find the size of the array, you are just taking the size of the operation called size of, we said in terms of number of bytes, size of the array over the size of the first element. Why can we do that? Because we know that the array always have the same type. And the size of the array can be allocated like as a fixed things, or it can be allocated in the memory in advance. So originally C++, you need to define these arrays essentially some lengths that you define originally, they were not dynamic. But here actually this is dynamic. So you can get a procedure and you will, or you can read n, and based on this n, you can have an array of n. Before, you need to just have a independent of n that you are reading, you need to have some constant essentially as the size of the array. If you want to use the array, you could otherwise you could also allocate some memory for that. But here is much more convenient in C++, especially C++ 11 and above. So as I mentioned, so this issue of that the size is fixed, maybe it's not the case in lots of languages nowadays. Like in C++ or Python, you can have arbitrary lengths. And generally, you can consider a equal to 1 to n, and you can access them ai of I. This is important. This is not just only for array, but also nowadays it is, for example, for vector. If you are using in C++ vector, you can also do it the same thing. Or also the mappings. That's another thing that also you can have it with this operation. So this a of this I, it has been essentially overloaded to have it for others, not only array, vector, mapping, etc. Great.
So then how about lists in Python? Because I think lists in Python can have several types.
Yes, in Python, yeah, it is more relaxed. You can have essentially a list of several objects of different things. But yeah, in C++, list also, has the same type. In Python, is more relaxed. So some of them is essentially are. In some sense, actually, you can consider the list that is considered in Python. All of them are strings. Maybe strings plus some type. Now you know that. So in some sense, everything is in strings. And whenever you want to get an element, you will get that one. If it is number, and then it turns that string to a number and give it to you. or if it is any other type. So in that way, essentially is also a set of string list in Python. But this is something that has been implemented to be more convenient. I mean, we can say that a of a to n, this is, we can have a more than one dimensions. And this is, again, the same type of things that in Python also, if you want to arrays and you want to have a fast array, you may use NumPy. So NumPy is the one that they have written these arrays and operations on arrays or vectors in C++. That's the reason that it is very actually nice and easy. One thing that I recommend is to try to bind C++ and C or C++ with Python. That's a good one, actually. I was working with my son on this one. He's actually 9 years old, and he actually could do this one. The interesting thing is the Siphon. So this is something that using Siphon actually is very easy. So that's actually a good way to try to bind C++ and Python. What's the meaning of that? It means that you are writing essentially in Python. So this is some Python program that you are writing, py things. And then inside that, you are some function, you may write this function in C++. Why do you do that? This is exactly the reason that, for example, as I mentioned, for NumPy, it has been happened that you can actually, some of these functions are written in C++. C++ can be actually much faster than Python. Like, for example, 4 in C++ are much faster than the 4 in Python generally. And the reason is that C++ is a compiler. It just turns the program that you write into machine language, but Python is an interpreter. So it needs to first turn it into some other language like C++ or some middle language. And that language, you can again compile it and you can get a executable file from there. That's the reason that if you have a Python program, if you want to write it, you need to write essentially just Python, the name of the program. But in C++, when you do it and when you create an executable file, I mean, then you can just write up the name. So this is the name here. So if this is the command prompt, say, so if here, or I don't know, maybe you can just say actually this one. But this is the command prompt. Here, you just mention the name. So this is in Python, but this is in C++ or C, because you are creating an executable file. Why? Because again, Python, you need this Python to run essentially your program. You can also make an executable file. It's a bit more messy. You need to have all the DLLs, which are lots of them actually are written in C++. So you need to have that one as well, such that after you are creating a Python file, also you create an executable file. But generally, the Python one are much smaller. Sometimes they will say that, or in the order of 10 to 20 times can be slow for some, at least for some operations. But C++ is the fastest one. I mean, C or C++ are the fastest one. So that would be an important thing. Actually, you can bind C++ and Python. There are several ways, but one of the simplest one actually that we could do it is using Siphon. And that you can write this one, the parameter. So the procedure that you want to do it, you can actually do it there. So that is important because for and one other interesting thing. So when you do that, so the issue that the data type in Python and C++ are the same, are not the same, and so you need to do some turning. Of course, from numbers, it's not a very hard thing. You can say this is the float or this is a integer, double, etc. That's the easy one. The main problem actually comes from strings. Here, but that's the interesting thing. So actually, you can send a set of, you can pass, you can write in the Python, you can pass a string to a C++ function. This is very convenient. That's actually the very important one. The same discussion that we had it here for the list that we discussed, actually a list in Python can have different type of records. the different types. But in some sense, that is everything is a string in some sense. So the same here. So the Python, using this Cyphon, essentially, you can test it. And one thing that you can do it, the most important one is that you can give a string from Python to C++. That's very convenient. Why? Because nowadays almost every data structure that you will consider it, you can represent it with JSON. So JSON is very important. How many of you know about JSON? Just raise your hand. Okay, so 3 people have mentioned that they know about JSON, which is good. Good. So JSON is very important. JSON is currently is I will say it is some kind of hierarchical data structure. It is a generalization of the one that we are talking about. And yeah, I'm just mentioning, and I will continue. I will say more about JSON. But JSON, there is something that essentially in Python, or like you can find a library in C++ as well, that you will take, and they take a JSON structure, and this makes this JSON structure. JSON in some sense is a very class that we are talking about here a bit later. And then they can take, you can consider JSON to strings. So then strings, you can go from, it can go from Python to C++. And then when you have the C++, you can come back, and then you can essentially, it's called JSONify, that makes it, so you can take the string, and then from this string, you can get the JSON. Why is it important? Because you can take any data structure, which is the JSON is very general things. And JSON actually, which is important because you can also save the same JSON in databases. These are the ones that is called non-SQL or NoSQL databases. So you can save the JSON in a database, and you can get it. And whenever you want to pass it to C++, for some function you want to do it faster, you can first make it as a string. Then a string, you can give it in this binding things that I have mentioned. When you bind it, you can pass a string from Python to C++. And then in C++, you have again, you can just, this JSON, this text, you can make it the JSON. You have all the information, then you can write your program for this particular procedure. That's very important. One other issue is that Python, for example, does not allow to do it parallel things quite well. However, when you pass this one to C++, in C++ there are very strong ways that you can do parallel algorithms. So you can have several fork, and several thread, and you will run it. So that's actually a very important thing if you want to have parallelism, also to use C++ to have a faster thing, or some procedure that you might have already written in C++. Now you want to use it in Python. Then that's also another way to bind these things. That's actually very important, I will say, because these are C++ and Python are probably the most important languages. Again, Java also you can consider that, but I will say either you will write with C++ or Java is a bit also slower than C++, or you are doing Python. And so binding this means that you can use both of these languages to have a very efficient way of writing program. Is it clear? Does it make sense? Please unmute and answer.
Yes.
Great. So I think I will strongly, recommend that you will go talking about this kind of binding between C++ and Python. There are several ways. I think the Cyphon one works very well. How many of you have done so far the binding between these two languages? Anyone has done it? Raise your hand if you have done it. Okay, so no one has done it. So that's a very good one, actually. I think that's a very good exercise. I will tell you, actually, go there and run this one. You may even want to use it in your a final project that you want to turn. And you may have some programs, some part written by C++, some by Python. They can do it. That's actually very, I think that's, you will get the beauty of both languages here. Great. Here, let's continue these things about the data structures that we had it. Good. So, as I mentioned, so in some sense, here you can have in the array, you can have a, I mean, the same type, and you can have a two-dimensional arrays here like this. I mean, here you can sometimes you are writing this one in different languages, it might be different. So you may write it this one in C++ or in Python. The records are similar to array, except that we are not assuming they have the same type. So in some sense, you can consider a list that exists in Python is some kind of, I mean, generalization of the records. Because then we don't need to have all of them have the same type. So it is the list of elements. The only thing is that the list in Python is dynamic. You can actually add to that. The records that we are talking here is generally are, I mean, have the fixed size. And in that sense, so this is the one that so here when we have these records, so these are very similar to array that I mentioned. You can have a different type. So this is the thing. So the size of the elements in a record are well known. However, this is changing essentially, has been changed quite a bit. So a record, it can be something like this. For example 1, it can have one integer, one array, and one name, which is essentially an array of integers. So it can have 2 arrays and 1 integer. But as you see, actually, this is very similar to the so this is the originally was the concept of a struct in C. But nowadays, everything has been changed. I mean, you may still use a struct, but the one that you are using it is the classes. So classes, not only they can have this kind of data types, but they can have also functions. So they can have both functions and data together. So you can have classes, but they can have both functions and data together. So that somehow is the generalization of record. And you can use, as I mentioned, the C++, for example, is the one that you can implement in the record. Now, but the classes, so this is the concept. So we had this concept of a struct. Or a record. So a record, we don't have a name, so that would be essentially a struct. So that we had only the data. And this data had a fixed size. That's actually the one that they were very good match with the SQL. So it is SQL essentially, but SQL. So this is very important because if you have such a data, then this record is a record of a person. In some sense, this struct or record would be a row in SQL. So how many of you know what is SQL? Please raise your hands. Okay, so SQL also is another important thing that you should know. That's very important. Good. So here, I mean, this SQL essentially is somehow a set of records that you will have it, and this is the database that we have it, and that's important because this is the database that you can save actually everything, and these are still, I mean, used a lot. So this kind of SQL stuff that was used for records. Now there is this generalization of record, which is, as I mentioned, this is JSON actually. So JSONs are more essentially dynamic than a record. A record, in particular, when we have this one, you know what is the size of the total record or strike. You know that this is, I don't know, say 2 bytes here for integers, 10 bytes of integers here, and this one. So you know what is the size of this record, or the size of the strike, or the size of the SQL, a row of SQL. For example, a row cannot be very big. I mean, like even if you have an integer, if you have a string, the size of the string can be, I think, 65K. So you cannot have more than such a string size in any cell of the SQL. So in some sense, you know what is this one, and you cannot change it then. So then we have this concept of JSON. JSON essentially generalization of this one, but it has a dynamic size. So in a sense, so it is the same things. In some sense, it is the generalization of classes as well. In some sense, JSONs are more like classes, because classes, they can inherit other classes and they can do that. The only thing is that JSON also, it is good, and this one it is used for NoSQL databases. So in the NoSQL case, we have the JSON. JSON essentially saved as a NoSQL type of data. And the catch here is that you have this one, and you can consider JSON a set of, I mean, like records inside each other. So you may have this, generally you can also write it as a, maybe also the generalization of a dictionary concept. What is that? So in a JSON, so you have exactly the same thing. You have, say, for example, int1. So this is an integer. So this is the same thing that you have. But it might be the case that now, for example, then you have name. Then the name itself also is a record. So it is this is the one that, so what is the name? It has another dictionary that is open essentially. So then in the name you have the first name. So this is the first, and then there is another one last. So in some sense, you will see that this is like integer. So in integer, then you will say name, but then the name dot, for example, first, and then name dot last, then it is another thing. And this, you can have this kind of recursive type of dictionaries inside each other. So you can, in some sense, you can also represent this JSON with a tree. So this is the first level. So this is int one. This is name. I don't know. For example, this one can be salary of this person. And then this name itself has two things. It has the first. And this is the last. So you see, this is actually very similar to we have some kind of tree structure. We talk about trees and others later, but here it is the same as also HTML and XML. These are the other type of thing that they have trees, because trees actually can represent better. So in some sense, JSON and classes, or classes that they don't have any function, or XML or HTML, these are very similar structures, but that's actually very common. Nowadays, JSON is very popular. And then here, JSON, the one that they can do it actually, like I think MongoDB or others, that they have a NoSQL type of database. In this NoSQL, the catch is that there is no this concept of row anymore. So we don't have this one row essentially that you can do the things. You have, for each record, we have a JSON now. So we are keeping this JSON, and the important thing about this JSON is that like they may have a different thing. So like some of these they may have first and last. Maybe some guy does not have any name and does not, the name is empty essentially for this guy. So they can have actually dynamic sizes. So this is the main thing, that this JSON is a struct or record. They had a fixed size. JSON can have a dynamic or different sizes, and that's the one that the particular languages that they can handle them are this kind of NoSQL type of things. That they are also fast. I think if I remember correctly, MongoDB or others are there, and you can do the operations much faster here. And you can, for example, insert a field, delete you can, in the JSON that you have a name. Maybe you want to say, I don't know, some other field that was not there. You can also add it, or you can delete it. So you can do some operations that, I mean, in SQL were different at least. You could remove a row or something like this. You could remove a column which is corresponding to a field in SQL, but that is a bit maybe less efficient than the way that you can do it with NoSQL. So we have this concept of a struct record, and we have this classes, dictionaries, and JSON and XMLs or HTMLs. All of them are using this kind of tree structure. Yeah, and you should actually go and read more about them. These are very important. These are, again, these are the things that coming quite a bit in interviews. So this is this concept, and from this JSON, as I mentioned, JSON is very, I mean, a versatile data structure, and almost anything you can mention to JSON. And as I mentioned, there is this function, for example, if you get a JSONify in Python, you can take any string and make it as make any JSON and make it as a string. So this string now you can essentially send it to any other procedure via binding or via some things called REST, like API communications. Send it to the network essentially, because it's just set of bytes or set of characters. You will send it, and the other person get the strings and then make JSON out of the string. There's a reverse operation, and then you have the whole dictionaries there. That's very convenient, and you can use it. Yeah, this, if you are using API type of thing, and if it's using the REST protocol, that's also, lots of these are in terms of JSON. Does it make sense so far? Any questions? Great. So let's delete our records. Good. So one other thing that is actually useful, is kind of the linked list. So as I mentioned, the array at least used to be the case that, I mean, you have a fixed size even at the beginning. Now you can have a dynamic size. The size can be different. But still the issue is that if you have an array and you want to insert an element here, then you need to shift all these guys essentially to this one direction such that you can do it. So inserting or deleting in an array is not a very efficient way. That's the reason that you can use actually a linked list. So these are the data structures that you can actually use it. And here, essentially, linked list is this one. So you have some kind of the data type here. And then you have generally a pointer. So this pointer can go to the next guy. So this pointer guy goes to the next one, and so on and so forth. And generally, I mean, this is a linked list. I mean, and you have this is the first element. So you have this first element, and then you have this that you have access to that, and these are essentially doing that. And at the end, when there is nothing here, is some kind of this. It is called this is null. I think you can say that null or nil or something like this. The last guy. There is those things. So this kind of linked list, you can actually have them. So in C++, we have this concept of pointer, and you can create actually this linked list efficiently. It is called double linked list if also this guy also not only goes to the forward guy, also has some backward things as well. So that's another things that you can have it here. And that's also this is called double linked list. And so in C++, actually, you can have these kinds of pointers, and you have it, you can implement them. We will talk about that. But also in Python, it is the case. So in Python, when you, essentially define a class, you can say you can define a class list, and then you can define essentially element next. And this element next actually is a list itself. So this element next essentially is also a list itself. In Python, dynamically we find the type of each element. In C++ also you can have this kind of the auto. When you put, instead of you saying something is int, you can just say auto. Auto means that a compiler should find the type of this database. But anyhow, in Python also, you can, in some sense, you can have actually this type of pointers, because you will say there is this list, it has an element, and it has a next. And this next actually is a, next by default is none. When you introduce a new things, but then this none can be, you can put actually next equal to a list itself. So in that sense, that would be a pointer to the next guys. So we have actually such a structure in Python as well, and we have both of this list and linked list in both C++ and Python. And these are the ones that we call it dynamic data structures. Why? Because we can insert, we can delete, and these are actually very good one to use. We will talk about this one. So the Python, you can actually check it. I will mention some of this in the STL. Good. And as I mentioned, pointer is something that refers so let me just do it a little bit. A pointer is something that we are using. That, as I mentioned, this is a list that you can have it, and a pointer is something that goes to the next guy. And we have it in C++. Generally, we are using it. This one in C++. This is the operation that we are using it. This is actually if you want to access to that, and this is if you want to find the address of something, we say address of p. If p is a variable, and you will put this one, sorry, the address of an element, you will using essentially this and sign. That means the address of p, and if you want to, if p is a pointer, if you want to put it, what is the value of that, you are putting it star p. Good. So there are two drawbacks for list, is that it requires more space because it not only has the data type, but it has the pointer. These pointers are not there essentially in the array. Probably is not a very big deal because nowadays the memories are quite large, so you can use it as much as you want. And the other issue is that you cannot this list, you cannot easily access to the ice elements. So you cannot say a of, for example, 10, because a of 10, or you can actually, you may use that one in C++ or Python. But the issue is that when you say a of 10, you really need to go this linked list 10 times to find these guys. So if it is like, say, is a large array, actually you need to go all the way to find these things. So it is different from arrays, because in array, if you have a of 10, you know exactly what is the address of this, and we could go there. For list, it is not the case. And as I mentioned, the main operations here is that you can actually insert an element in the middle, or you can delete an element. Any questions so far? And again, like in Python, for example, if you want to have a linked list, you can define it as a class. So in some sense, Python, everything is a class that you can define it and use it. Any questions, comments? Please unmute and answer. Good. So the other two operations, which are actually very convenient, and this is the stack. This is a very important one. So it is a dynamic structure that we can delete. So essentially, a stack is the one that we are putting these guys in a stack, and we can always delete the pop the element that has been most recently inserted. So here, the concept is the last in, first out. The person, so you will put it essentially here, 1, then 2, then 3, and then 5. So always you have access pointer to the last guy. So you can pop it, or you can actually you can pop it, or you can insert it. When you go the insert, so there are 3 main operations. There is a top. What is the top element? And then the question is, then you can pop and push. So these are the, I mean, the way that you can write it. So you can actually represent this one with an array. So if you have an array, you can actually, or a vector in C++, you can do that. Why we have an array S, and then this is a top. So if t is equal to 0, t equal to 0 means the always you have this pointer t to the top. If t is equal to 0 means that I mean, return -1. There is nothing. It is empty. Otherwise, you return s of t. So okay. So here we are assuming that the elements will be from 1 to n. So the array indices. So you will be 1, 2, 3, 4, 5, and so forth. So if it is 0, means that if there is no element here, essentially it essentially returns 0. Otherwise, you just return the top guy. Now, what is the pop element? So if t is equal to 0, then returns underflow. It is like essentially if this array is empty. Otherwise, it just returns the top guy. Just reduce t1 and then returns the top guy, the previous top guy. Or you can change the operations here. The same thing for push. So push is easy. So you always increase t by 1, and then you will add this new element push on the top of this. So these are the 3 elements that you can do it. All of them are takes order 1, and you can also implement this by this one. You can also implement it via linked list. And one other important thing, like now, for example, if you are using C++ or others, you can actually do more than that. You can delete, insert, and you may actually insert it even here. But note that whenever you do this operation, it takes actually possibly linear time. So these other operations, the push, top, and pop, these only all take order 1. Everything else actually can be order n, or at least log n, depending the way that they have implemented. We will talk a little bit more about them. So that's about these things. Any questions? Good. So the next one that we want to talk about is our queues. So Q is another data structure. So we have this things. This was the stack. That you could always actually insert or delete on the top. And one other important thing that I want to mention, actually, this stack is the one that there are lots of problems if you go for some interviews, essentially for internship or getting a job. So the stack is the type of thing that they are asking lots of questions from you. And this is a very, there are some actually nice problem, cute problem, not that easy to, I mean, if you know the solutions are not hard, but if you don't know the solution, it's not that easy to get it. So they are based on a stack, essentially. If you have a stack, then you can do insert and delete, and you can actually solve this problem. So try to get familiar with that. And again, for example, in Geek4Geeks or other things like hackerranks or I don't know, LeetCode, there are several examples that they are using a stack and list and others, queue as well. So queue is another data structure in which the elements are deleted, or dequeue is always has been inserted for the longest time. So this is the things for the queue. This is for a stack. What do we have for queue? So we have two elements. We have head. Sorry. Actually, let me just. We have head. And we have tail. So instead of one that was only the top, we have two things, head and tail. And this is a structure which is called first in, first out, FIFO. The guy that first coming, that's the one that we will take it out first. This is different from the one that we talk with the stack, that last guy was the first one that it was going out. So we always insert at the tail, and we will delete from the head. So that's the difference. So, and you can implement it both by array or linked list. So, and interesting things here is that, I mean, this is the way that you can actually do it by an array. So we have two operations, enqueue and dequeue. So what is the enqueue? I mean, essentially you will yeah, I think yes. So here you will insert. So that was the thing. So that is actually. So here you always insert here in the tail. This is the head. You will insert here. And here you will delete from head. So good. So when you want to enqueue, so what do? You want to put index this q x. So then you will put x essentially at the tail, the current tail. Then if tail is equal to the q length, then you will say essentially you are done. Otherwise, you just increase tail by 1. So tail will be increased by +1. So you always essentially advancing the tail. And you can have a dequeue. The dequeue is the one that you are getting some elements from the head. You will get this guy, and then you will remove it. And you will just essentially you are advancing head to the next step. So you can actually consider this one. So let me actually draw it this way, that might be better. So you have always head, and you have always T here, tail. And you are inserting here, and you are deleting from these guys here. So you delete here, and then you will insert here. The problem here is that, I mean, the size of the array, if you just do it, if as a linked list you are implementing it, that should be fine because you can just delete easily. But if it is an array, then the issue is that the size of this array becomes just larger and larger because you are deleting from the beginning and then inserting at the end. Actually, you can implement this one with a circular array. What is a circular array? So essentially, you can consider all of this in a circle. So always there is head here and tail here. And then you are deleting from the head, you are inserting from the tail. And here we mentioned that if tail is equal to length of the queue, when we have a problem, when the queue is full, when the tail and the head becomes equal, in that case, it means that you have full element you cannot insert and you can give an error. Otherwise, the head goes this way and the tail is going that way. Now, the issue is that how can we have this kind of circular arrays? So that actually you can do it by the mod operations. So you can say mod operation or percentile. So this is the one that you will mod length of the array. So if the length of array is, so I will say array length. So the time that you create an array, you are saying what is the length of this array? Or what is the length of this queue? So you define it. Now, this is the thing. So now when you have an array, so we have, in some sense, we have just an array. We don't have the circular things. But the issue is that when you guys, you are advancing this guy, the tail, for example, you are going it, and you will say tail is equal to tail plus 1 mod q length q, or mod the array length. So here the lengths of the queue and this array length, these are the same. So you can say this is mod this one. When you put it mod, then essentially it means that if it becomes the length of the array, it will come back and start from the here. So the head is coming. So head is coming, and again, when it is full, then you will go at the end of the array. So in this case, you are guaranteeing that with a fixed size array, that would be the size of the queue, you can actually implement this queue. And it is not the case that just tail is going forever and head is going, and then this size of the array, it becomes very large. With a fixed size array, you can do that. And again, you can do this one also by linked list. And that is a very good way of implementing these things. Good. So any questions? And again, for example, if you go in the C++ and others, even Python, like if you consider the list, for example, all of them, they give you this operation that you are doing something in the middle, ice element for some of these data structures. But note that whenever you are using, that's not a standard one. The running time of that, how it is just one operations, one function, but the running time of that is depending to the n, the size of the array. So these are not order one operations. That's the thing that you should, I mean, they put for you for convenience, but the running time, it might be not n. It depends on how do they implement it. If they sometimes this log n instead of n, but sometimes it is order n. So these are slower operations than other operations that we see it here, for example. Does it make sense? Any questions? So these are some basic things that we have it. Oh, there's also another thing that I want to talk about. This is a dictionary. Let me. We talk about hashing, but this is the other thing that we are using. I mean, there's a dictionary. This is a, several type of dictionary, both. So dictionaries in Python. So for example, in the dictionary, this is just a mapping. So we have a dictionaries, which is in Python. we have this kind of map, which is in C++. C++11. C++11, I think it means that the year was 11. So here, both of them are the same thing. So instead of you have a dictionary that you are doing, you have a, I don't know, a mapping that here you are giving some key to that, and you will do that. So the mapping, this is a very important one. When you have the mapping, each of these have only one value. So for each, this is called keys. So both of them, this is called keys. So you will give this key, what is the value for this key? And both of them are, actually we have dictionary in Python, and this is this one. And both of them are essentially based on hashing that we talk about them. But this is actually a very good operation. So you can, in some sense, this is also a generalization of array. Because in array, we had the numbers 1, 2, 3, 4 to n. These are the indices of the array that we are doing it. But here, both of them, the dictionary and mapping, is a generalization of that. So in some sense, the same way that we mentioned in a linked list in C++ are not they can have a different types in it. So the same thing here. Now with mapping, when we have it, you can give anything essentially here as the mapping. So they can be different strings. So there is no need to be this number from 0 to n that we had it for array. That is becomes actually very convenient. So in some sense, this is, of course, the size of this should be fine, the size of the dictionary, but they have, I mean, implemented the best way of doing that. So when you have it, then you don't need to say array 0, 1, 2, 3. You can talk about the names. So for example, array Mohammad. So when you say array Mohammad, so you can say array, or you can say, I mean, essentially this is the, so instead of just 0 to 1, you can say array Mohammad. Of course, the question is that Mohammad is where is it? And the size of that should be, I mean, okay, because how many words do we have it? But that is type of things actually that it is already implemented in dictionary operations or mapping in C++. And these are somehow generalization of array that makes the life much easier. The indices of the array can be anything, not just 0 to n. And even actually this mapping can be very general. So some of this, you can, in C++ that we will talk, you can give graphs. So you can have the whole graph and map it. So any data structure that you want to give it, you can give it here, and it maps for you. The same thing in Python as well. So any data structure that you are giving here, it maps for you. So for the whole graph, you may define some value of this graph. And then wherever you will call the graph, you will give it. So in some sense, this array part here, it can be any data type. You can think about it in some sense that this graph that you are getting it, you will make this one some kind of a string out of it. Again, the same idea that I have mentioned. When you want to do a communication, all of these communications are happening by strings. So in a sense, it is the case here. When you have a graph, any data structure, first we will make this one into a set of characters. Characters and bytes are the same. So characters, or like, this is essentially a byte. It has 8 bits. So the same thing for characters, you have 8 bits essentially. So first you are just changing it to this kind of numbers or characters or whatever you want. And then when we have this kind of data structure, which is in terms of bits, then we can map it using hashing to some data structures, and then we can use it. So that's another thing which is very important, mapping a dictionary, and we are using it. So one thing that we will talk in this class, some of this we mentioned. We also mentioned somehow 2 things we want to mention. What are these data structures? How we can implement them? What is inside that? And of course, what are the current ones that are implemented and we should use them? So you don't need to implement all of them again. But it is important that you know what are the inside operations. And for example, don't consider any function there. It is order 1 time. Some of them actually order log n times or order n times. They have implemented the best way, but when you consider it, you need to be careful, and essentially your algorithm would be more inefficient if you are using those functions that it takes more time. There might be some other function that you are just using the regular one, which are ordered one time, such that you have a more efficient algorithm. So this is essentially the thing that happened. Before, maybe we could say that any basic operations, maybe now basic operation has been changed, because in both Python and C++, now you can do insert. Like if you have a linked list, you can, if you have an array, you can insert anywhere essentially. Or if you have a stack, or if you have a queue. But still it takes more time, and you need to see what is the data structure that they have used it, such that you know, for example, for linked lists or other things, they are using binary trees actually. Then the binary tree, then some of these operations becomes log n instead of order one, but it is not as bad as order n. So you need to know what is inside, such that you can write the most efficient way. And the other issue that these ideas that we are discussing here, these are the ideas that you can actually, you can make lots of problems solvable by queues or stacks, or the ideas that they have been implemented. So we talk about especially binary search. Binary search is a very general idea. You can apply it for lots of problems. This is not something that you can just do it binary search in an array, but you are using the ideas of binary tree or the vision that binary search that it gives to you, such that you can implement some other algorithm. And these are exactly the type of question that you will see in lots of interviews. They really want to make sure that you understood this concept, I mean, in your heart in some sense, and you can consider any generalizations and other things. And that's the thing that we will focus here. And we have mentioned it. Next time, I will give some brief overview about STL for this C++ that have almost all these operations that we are talking about. And then we are going there and we talk about the rest of them.